Okay, you're all welcome to today's class. You're all welcome. You're all welcome to today's class. So we are waiting for others to join. So I've sent some past questions to the group chat. So you can download them. So those are the ones we are going to be starting with. So we are waiting for others to connect. Hmm. What? It's next time. So we are still waiting for others to join. So do share the link so that others can benefit. Hmm. It's working. We are still waiting for others to join. Okay, for those that want to go and pray, you can go and pray. So we use that opportunity to wait for others to join. So in the next 10-15 minutes, we start the class proper. So I've sent the past question to the group chat. So you can download it so that we have a look at it. We are starting from that today. So we have 35 questions in all. The first page 1 to 16, and the second page 17 to 35. So 35 questions in all. So you are all welcome to today's class. So the class starts properly in the next 10 to 15 minutes. So we are using this opportunity to wait for others to join. So for our Muslim brothers that want to go and pray, they can go and pray now. So for those of you that have not subscribed to the YouTube channel, please endeavor to do that. So try and subscribe to the channel so that you can be among the first set of people to be notified whenever we go live. Okay? So the class starts proper in the next 10 to 15 minutes so that we wait for others to join. So we connect in the next 10 15 minutes. Okay, we start in the next 10 15 minutes. We are still waiting for others to connect and join. So the class starts properly in the next 10-15 minutes. In the next 10 minutes, we start the class properly. So for those that want to go and pray, they can go and pray now. So in the next 7-8 minutes, we start the class properly. So we are waiting for others to join. So that's why the light is off. So in the next 10 minutes, we put on the lights so that we start the class properly. Okay. Yeah, welcome back. So we're about to start the class now. So we start the class now. Okay. Okay. So the past question is already on the group chat, on the phase one group chat. You can go and download it from there. So it has two pages. The first page, it contains from question number 1 to question number 16. And the second page, it contains from question number 17 to 35. Okay, so we start the class properly now.
Okay, good evening, everyone. As earlier discussed, we are going to move on to the Maths 101, and our attention is to solve some questions. We believe that you have read extensively for this exam, and if you have any question, let us know during the course of the class. So we have a past question here which has been copied to you on the group, please. You can check it, and some of you might have even had the past question. This is 2020/2021 semester exam on the Math 101. Okay, we go straight because we are already starting behind schedules. So we go straight to the point. I hope that you have the question once again with you. So the very first question here is asking which of the following is correct. And you will be noticing something. For example, the option A is giving you 1 degree greater than sine 1. Well, if you look at this, you can see that this one is in degree, while you do not see anything here. But presumably, it means that you are dealing with it in rad. So in all those areas that you do not see any unit, it simply means that they are in rad. So our attention is actually to compare the 1 degree to 1 rad, because everything is on 1. So we are not talking about something greater than 90 degrees. So beyond 90 degrees, so we have another one entirely. But for now, it is 1 degree and then 1 rad. The major conversion between both of them is that if you want to remember easily, is that 360 degrees is the same thing as 2 pi rad. And that one means if you divide both sides by 2, 180 degrees equals pi what? Rad. And if you decide to divide both of them by rad, then we have 180 over pi equals 1 rad. At the end of the day, your pi, don't forget, it is still our 3.142. So if you now look at it, that even if you divide 180 by 3 points, even if you divide it by 4, then the value you are going to have in degree is going to be much more than the value in this one. So, in other words, what you mean is that every 1 rad is actually greater. Every 1 rad is actually greater than 1 degree. Every 1 rad is greater than 1 degree. So, because this one, by the time you divide it by 3.14, you're going to see that 1 rad is more than that 1 degree. So, option A that says 1 degree is greater than 1 rad is wrong. Option B, that one is okay. Sine 1 degree less than sine 1. Yes, it is less than sine 1. So option B is correct. Then we are having, so that's the major correct option there. The other options, so yeah, so that is under that one. In case you have question, please let us know. So 1 degree is less than sine 1 degree is less than sine 1 rad. So alternatively, you can press the calculator, but I don't want us to do that because we don't want to. There is a problem whenever you are converting between degree and rad. So some people, out of anxiety or negligence, they will not remember to return it to degree. Once you open your calculator, it is usually in degree. And if you convert it to rad, you should remember to return it to degree because most of your operations are done in degree. So which is another way around for you to do it. By the time you press this and you press this, you get the answer from both of them. So that is under that one. Number two, we are moving on to this one. In number two, we are having a question on complex number that is asking you to find the modulus of 4 minus 3i. 4 minus 3i. So in this one, you should remember doing the modulus is having square root of 4 squared plus ignore any negative 3 squared. And by the time you look at it, this one looks straight. This is 25. So square root of 25 is going to give you 5. So the option there is the correct option there is A. So the next one, this one is asking for both the modulus and the argument. So in this one, they ask you once again that you find the argument of this one. After you have obtained the modulus, you can find the argument of it. So, well, to find the argument, you have to, because it has a negative, this is a complex number. Your argument is equals to arctan y over x. But then, since that it has a negative, you need to be very careful about the use of this one. You need to be very careful. In that case, since we have a short time to spend here, I will advise you to actually take out your calculator and find the arguments. But for some of us that want to know the pattern at which you are going to do it, you are going to change this one to tan for a reason, because it has a negative. Either there's a negative here, or both of them even have negatives. So in that case, we are going to ignore the negative in the meantime. That's why I call it 5. So in which we say 3 over 4. And from our calculator, the arctan of 3 over 4, and now we check the arctan. Is 36.9. You can check yours. I believe that you have your own calculator. 36.9 degree. But that's not the answer, because you have not taken care of the negative. So by the time you draw it on Argand diagram, you can see that this is a positive x, while this one is a negative y. So it falls on the fourth quadrant, and for which we say 360 degree minus what we have earlier. So our answer here is 323.1. 323.1 degree. That is under that one. So the options we have there are quite different from this. So let me use the complex one. 4 minus 3i So that is so the option, I've even checked it from calculator. The calculator is still giving the same thing as earlier. So the option is not, the correct option is not there. Then number 4, the fourth term of a GP is 16. The fourth term of a GP being GP, we call the general expression for it, which is AR raised to power which is ARN minus 1. So in this case, we say the fourth term. So our T4 equals AR cubed, and so the answer is the value there is 16. Why the seventh term, which is AR6, the value is 128. Find the sum of the third term and the common ratio. Find the sum of the third term, S3. So, and the common ratio, R. So, in this one, the ratio, let's quickly find the ratio. The ratio is T7 over T4 here, which you can see that the A cancel out and we have R raised by 3. At the same time, if you follow it from here, 128 over 16. So your 128 divided by 16, I want us, gives us 8. That is 8. So R cubed equals 8. R equals cube root of 8, which will give you 2. So the common ratio is 2. So if the common ratio is 2, you can even proceed to find the first term. For instance, since that you have known T4 already to be 16, you can find that one. So, but we are not being asked to find that, but nonetheless, let us actually work towards that. So our T4 is 16, which is A raised to power 3 or 16, A into 2 raised to power 3. And that one will give us 8A16. So A is also 2. So A is 2, the ratio is 2. So the first one is 2, which is A. Second one, AR, is 2 times 2, 4. Then third one, AR squared, which is times 2 again, and to give us 8. It's the sum of the, so we have the sum to give us 14. So the sum is 14, the ratio is 2. The sum is 14, the ratio is 2. So the option there, find the sum. So the sum is 14. That is option B. And the common ratio, well, the options for the common ratio are not stipulated. So we ignore that. So option B. So the number 5 question says that suppose 5, suppose our U okay, we are having U to be A, B, C, D, E, F. And we have three other sets, A, B, C. Our A, the elements, the A, we have AC. Set B, we have BCF. And set C, we have BDEF. So we are asked to find A complement intersection B union C. Okay, that one is not a complex, it's a question mark. So in this one, we are looking for B union C. B union C, we can see that we have B, C, D, E, F as the union between B and C. Then intersection of A complement. So we can see that A complement should be B. Then we have DA is there. You can see that there is no B. C is there, so D, E, F. So in this case, what is common? What are the common sets there? B is there, D is there, E is there, F is there, which returns our A complements. So the options B, D, E, F, that is option A. Option A. Then another question, we are still on that. They asked us to work on this. What will be A intersection B union A intersection B prime union A prime intersection B. So let's start looking at them. The intersection of A and B gives C. Then union A intersection of B prime. So if you look at this, these are B prime. So meaning A, D, and E. So what's the intersection of B prime and A? You can see we have the A, so that is A. Then let's clear the intersection. We are dealing with union. Complement of A, that should be B, D, E, F. Intersection B. So we have B, we have F. So B and F. B and F. Everything A, C, A, B, C, F. A, B, C, F. So, and we have to get the answer out. A, B, C, F. We have to actually get the answer out. A, B, C, F. That is A union B. Look at it. A union B. That is A union B as our answer. So that is another one. Let's move on to another one. That is option B. Option B. Option B. So let's see whether it still covers. No, it does not. So we clear the list of the sets. Let's proceed. Please, once again, you can make your comments. You have one or two that are not clear. So we try to see what you can do to that once again. So Z in number 7, Z1 equals 2 plus 5i. Z2 equals 4 minus 3i. So find the distance between Z1 and Z2. The distance between Z1 and Z2. So if you look at this, for you to quickly get what they mean by that distance, remember the Argand diagram. Forget about this for now. So your Argand diagram, if you have two complex numbers, the first one here, Z, let's call it ZE, I will call this one ZB. The distance between the two is this one, that's the distance between both of them, which in the first instance is going to be another complex number and its modulus. So first of all, find the complex number and its modulus. So the distance is given as this, which is subtract, then find the modulus. So from here, when we subtract 2 minus 4, we give us minus 2, while 5 minus minus gives us 8. So from here, we have the modulus 2 squared plus 8 squared. That should be 64 plus 4, and we are going to have 68. Square root of 68. And when you press the square root of 60, so that is the calculator, yes. But this one is positive 5. While this one, so when we subtract, so the option we have here is not among them. So for us to find the distance between the 2 points, so the options are quite not what you have here. So the next one, number 8. Number 8, we have to simplify 3x. Okay, we have to split, not simplify, into partial fraction. So we have 3x minus 37 we have 3x minus 37 over x plus 1 and x minus 4. We are to resolve it into partial fraction, in which case we have a over x plus 1 plus b over x minus 4. So in minus 37 is equivalent to saying ax minus 4 plus b x plus 1. So in this case, when we quickly use when x is 4, this one becomes 12 minus 37. This one is gone, and this one becomes 5b. So our 12 minus 37 will give us minus so it gives us what? Minus 25. And making 5b, for which b equals minus 3. Now, at this junction, since there are other minus 5 rather, at this junction, since that we are having what's it called options. So it's not a must that you quickly look for a. You can look at the options and see where your b is negative 5 sitting on top of x minus 4. So, and we now have two options, B and D. If you have only one option, you don't need to care about the next. But if we have two options such as B and D, then it is now it's a must for you to find our A. So when x equals minus 1, this one becomes minus 3 minus 37, that is minus 48, equals A minus 1 minus this, that is minus 5, for which we have minus 5A and A becomes 8. Now between B and D, B gives us 8, whereas D gives us 3. So option B is correct. So that is under that resolution. But don't quickly try to work the rest until you just check enough for you to beat the time. So we have another question here. So a tower subtends an angle 30 degrees at a point on the same level as the foot of the tower. A tower, this is a tower. Let's use the line to represent a tower. So subtends an angle 30 degrees at a point on the same level. At a point on the same level as the foot of the tower. So let's look at this is the foot of the tower. So just like a ground, for example. So an angle of 30 degrees at a point on the same level as the foot of the tower. At the second point, h meter above the first. H meter above the first, the depression of the foot of the tower is 60 degrees. So now say that as a second point, h meter above the first. So if this is the point, so suspend an angle 30 degrees at a point on the same level as the foot of the. So at a second point, excuse me, please. Please hold on, please. Okay. We are going to review that one because of the explanation there. So because of it's not, the clarity is not actually being seen here. So for that, we review it again. And in that case, let's move on to question 10. But you are going to see how to review this one because of the same level, the way it is interpreted. So number 10, in a pool of 50 students to see whether they speak, okay, two languages, to observe that. Okay. The universal set, the number of the universal set here is 50. To see whether they speak either Hausa or Tiv language, it was observed that 25 speak Hausa. The number of people that speak Hausa is 25. 20 speak TV. Number of people that speak TV is 20. And 5 speak both language. So both language, it means the number of people so is 5 both languages. So determine how many students speak neither. So you got none. So you can quickly have the set to understand that the number of people that are speaking Hausa is 25. The number of people that are speaking TV is 20. And those that speak both of them is 5. So from here, you can see that the remaining year should be what? 20, while the remaining year should be 15. So by
Exactly.
okay. So the number of those that are speaking, so let me rewrite it because of the clarity. So we are aware that the universal set here is 50. The universal set is 50. Those that speak Hausa are 25 and TV 20. Then those that speak both languages 5. So in terms of set, then if you look at it, 25 minus 5 will give us 20 outside only. Then 20 minus 5 will give us 15. So 3 only. And when you sum both of them, it will give you 40. So the question now says, determine how many students speak neither language. So since that we have 50 in all, and we have accounted for 40, it means neither is 10. And that is option B. Option B here. Then we move on to the next one. Move on to the next one. That is number 16, number 11, sorry. 16. Y minus 1. Y minus 1. If you look at this, we have to simplify. We have to find y. Well, the question should be to find y. If you look at this one, we can express it easily. Let's express it as a base of 2. So in this case, it means 2 raised to power 4, 3y. Then this one, 2 raised to power minus 2, it comes up. Y, this one is 2 raised to power 5, then y minus 1. So this one will give us 12y equals 2 raised to power minus 2. When you open the bracket, 5y minus 5. So forget all the bases of 2, we have 12y. Okay, before you do that, for clarity, it means 2 raised to power 12y equals 2. So remember the law of indices, so minus 2 plus 5y minus 5. So you can cancel it and say we have 12y minus 2 plus 5y minus 5. So when you allow this one to come here, it becomes 7y, and this 2 is minus 7, for which y is minus 1. So that is option A. Option A. So I hope that it is clear. Let's move on to the next one. So number 12. Number 12. If R is a relation defined on N, so R is a relation defined on natural number, that is your N, on natural number. So our R equals X such that we have X, okay, so, X, so that X is a what? X is a prime number less than 10. So then the range is, so we are dealing with prime number that is less than 10. Prime number that is less than 10. So let's look at the members of the prime number except. So we move on. So in terms of the prime number, so many people make a mistake of putting 1 there. It is, so we have prime number 2, prime number 2, 3, 5, 7, 9. Those are the prime numbers that are less than 10. Less than 10. So when you look at the options, so those that are less than 10. Okay. Oh, sorry, 9 is not there. Sorry, I want to say something on that earlier. So we have 2, 3, 5, 7 as your prime number less than 10. Because that line is. Then we are dealing with x squared. When you square them, that is 4, 9. That's why I said that one time. 4, 9. And this one is 25. While this one is 49. So 4, 9, 25, 49. That's option D. Because you are actually looking for sets of x squared, such that x, set of x squared, such that x is a prime number. So the answer there is option D. Then the next one, once again, we are back to partial fraction. So resolve, that is number 13. Resolve 3 over x squared plus x minus 2 into a partial fraction. So for us to do this, we are going to factor out this one, in which is going to give us x plus 2x minus 1. So when you factor it, we have this, and for which we say a over x plus 2, b over x minus 1, as we did the other time. So a x minus 1 plus b x plus 2. So when our x is 1, when x equals 1, there is nothing to add, there's no x at the left, so it means 3, while our b is 3b. And this side is 3b, and you can see that b equals 1. So since b is 1, like we said, you may just look at the options. So in looking at the options, we have positive 1, option B and option D. So let's proceed and find the other one. So when x equals minus 2, this is 3 equals a minus 3. Under this one, so minus 2, minus 1, minus 3. And here, we have it as minus 1. So a is minus 1, b is positive 1. In other words, negative 1 sits on x plus 2, while positive 1 sits on x minus 1. So, and since that it's not about A and B, take note of this. You could have used P and Q, you could have used C and D, you could have used any other letter. But at the end of the day, always know which number sits on which number. Because this time around, we have said that the first term here, which is negative 1, sitting on this, while positive 1 sits on this one. But mathematically, we prefer to write the positive one before the negative one. So you may see the option as this one because its own value is positive, so making 1 over x minus 1 as the first part, and this one that is negative will now be written as the next one, and that is in that case we have x, that is minus 1 x plus 2. So either you see the option in which this one is minus 1 and 1, or you see it like this. But more importantly is that negative 1 sits on x plus 2 and positive 1 sits on x minus 1. So don't confuse yourself because all the options here are very, very similar to one another. It's because everything is 1, 1, 1, 1. So in that one, option A is the correct one, where we have this, and if you look at it, you can check it. Option B is quite different because both of them are positives, and option C, they give this one, option C. So option C is wrong because it is x minus 2 that they are putting there. So please, out of the fact that you are under examination tension, do not make a wrong choice. So option A is the correct one. So the next one is number 14, in which we have if sine x plus y over sine x minus 1 y equals a plus b over a minus b. A minus b. So the question says that what is our tan x over tan y? So we have different approaches to this. We can actually expand it and see what they are focusing on, knowing fully that our target is on tan x over tan y. So in this one, if we decide to open this one, we may actually say sine x, sine y plus the other one. At the other side of it, since that our target is to find tan x over tan y, we know that tan x over tan y is actually sine x. So in which we are going to make some adjustment to that. For example, tan x over tan y is actually sine x cos x dot. This one, we invert it. Instead of saying divided by just a times and you invert it, it's giving us cos y sine sine y in this one. We are able to see that this is actually the expression we are targeting. But then the issue is this: can we have this expression from here? Yes, let's look at it. So this one is sine x. By expanding it, we have cos y plus sine y cos x. Everything over the same thing here. Sine x cos y minus then sine y cos x. Don't forget this is a plus b. That is not the challenge. Now look at this expression. We need sine x cos y, which is sine x cos y over cos x sine y over cos x sine y, which is this one. So we can just say that we divide here by this same expression. So if you divide this one and this one by sine y cos x, so this one will give us sine x cos y over cos x sine y plus 1. Why we have the same thing here, so the same expression. But not to waste our time, we know that this one will give us this expression, so tan x, our tan x over tan y, or like we said, this one is plus 1, while this one gives the same expression of tan x over tan y minus 1. Don't forget that everything still goes to a plus b, a minus b. So let's make this one like p, because it is what you are looking for. Let's call it p. It means p plus 1, p minus 1 equals a plus b, a minus b. So our target is to find p. So p a minus b equals p a plus b. So when we look at this, to make our p subject of the expression. So if we open everything, we pack them here, p a minus b minus pack everything here, a plus b equals 0. Yes, we have p outside, a minus b minus a plus b equals 0. So when you open the brackets here, a minus a is gone. This is minus 2b equals 0. So it's either that p is 0 or b is 0. But our target is to find p. So our p here is going to be 0 based on this analysis, and for which the option there is none of this. So none of this based on what we have here. So that is under that expression. So in case you have a question, let us know. So where you may have a question here. So that's under that one. The next one is on mapping. The next one is on mapping that says if f of x equals x squared minus 1 and g of x equals x minus 1, we have to find gf of x. Okay. So in other words, we have to just move on like this. The first one, and we know that it gives us x squared minus 1. So that is f of x. So we need to work on f of x before g of x. And then what is g of x? If we have x, all what we need to do is to subtract 1 from x. So if we have x squared minus 1, we still proceed by that pattern. X squared minus 1, then we subtract 1 from it. So from which we have x squared minus 2. X squared minus 2, that is option B, under that one. Then the next one, which is number 16, what is the image of 1? If a function, okay, we have this one, f x is having 2 square root of 9 minus x squared. So in other words, this one stands for your x, while this one stands for your function of x, which sometimes we call y. So they are asking what is the image of 1. So when we insert 1 into this expression, what are we going to have? 9 minus 1, 1 squared is 1. 9 minus 1 is 8. So we have 2 square root of what? 8. And we know that square root, that is square root of 4 times 2, which is 2 here. This one will give us 2. So 2 times 2, 4 root 2. We have 4 root 2. That is option C. That option C there. So we can turn to the next page. The next page, number 17. So this one is a complex number once again. If x plus y, if x plus y plus I, x minus y equals 5 minus I. So everything is in Cartesian form, so we just need to actually separate this. Ask us find values of x and y. So we open it, x, we just factor out x, factor out y. So x plus y plus ix minus iy equals 5 minus I. So your x, in this case, you want to find your x and y, or better still, why can't we even solve it simultaneously and fast? That will be faster. So this is real part, while this one is imaginary part. So for the real part, which is x plus y, must be equals to 5. Equation 1. For the imaginary part, x minus y equals minus 1. Imaginary part of this one, minus 1. That is equation 2. So when you add 1 and 2, we have 2x and we have 4 here, for which x equals 2. Like we said, you can quickly look at the option that says x is 2. So we have options A and C. So meaning that you still have two options. Now, after you have known x is 2, you can put it here. When x is 2, then automatically y is going to be 3. So x is 2, y is 3. And the option there is option A. That's option A. So we move on to the next one. And that is a number, the radius of a circle whose arc length. So this is circle, arc length from here to here is arc. So our L, arc length. Of arc length, the arc length is given as 15 centimeter, makes an angle of 1¾ rad. So the angle it makes is 3/4 rad. So at the center, we are asked to find the radius. So if you could remember, this is our R. Our relationship is that this our length of an arc. The length of an arc, L in this case now, is equal to r theta, equals r theta, provided that theta is in rad. But remember, in the O-level days, you used to remember that L equals theta over 360 times 2 pi r. So that this theta is in degree, while this one is in rad. So we do not need to say over 360 and so on and so forth. So we just stick to this expression. So our length is 15 and our r is unknown, while this one is 3/4. So by the time we say 4 times 15 over 3, that one is 60/3, that one should be 20, and that is option C. Option C, 20. So the next one is asking of chords. Chords 7½. What is the value of chord 7½? Of course. So this one you can use calculator to quickly find it, or you can still pass through a long step. So chord 7/12 is the same thing as saying chords. So make it improper fraction. That one is going to be 15/2. So we have that expression. And in this one, you may remember that we are still talking about chords, which means 1/tan or you can say cos over sine. But in this one, we prefer to go for the 1 over tan 15 over 2. So with all the options in short form here, so we can use your calculator to get the answer if it's going to be in short form, or you can just try to work it out in that order. Now, how do you work it on? You can use what is called half angle formula, and that one is going to be a long step because of the 15 we are actually dealing with. So in our half formula of it. So, but advisably, because of the exam, because tomorrow is the exam, advisably, if you don't have an idea on this one, all what you just need to do is to actually press this one from your calculator and check what answer you are able to get. Compare your answer with the options. So when you compare your answer with the option, you'll be able to actually tell which of them is the correct one. So by pressing, let me just try to do one. By pressing 1 divided by tan of 7.5, I'm able to have an answer here because I'm using 991 ms. So Casio 991 ms, not the natural display. That one gives me 7.6. So not in short form, but the options are in short forms. So all what you just need to do is to be pressing the options if you are using this black one. So the which is called Casio 991 ms. So you can actually look at what options you are going to have there. But if I'm so to have a suggestion because of what I'm seeing as options here, I will rather go for option A or B. I will not bother myself on option C because option C is not giving us 7.6 at all. That option C is not going into that. Let me 1 divided by down 7.5 was it? So it's not 7.6. So option C is not there. If you look at option C, it has at least 2 negatives that are going to reduce this value. Well, we have option, let me work on option B. So if option B is not going, then it means the only option left is option. So root of 3 plus root of 4 plus root of 6. Exactly. So that is 7.6. So the correct option there is B. So because I can see that everything there. So for example, look at it. You say root 2, you say root 3, you say root 4, and you say root 6. So I know that root 2 is 1.414. Let's just say it's 1.4, for example. This is 1.7. So you can see that even if you are working on these two together, it is now 3 point something, and you are still going to 7.6. Why this one will give you 2? So it has now turned to what's it called? 5 point something, and of course, you are moving on to this one that is also 2 point something. That is why that option is a better option for you. So you need to be smarter in your choices so that you don't waste your time. The number of ways in which the letters word and range can be made such that both halves do not come together. So we have a word arrange, and we are being told that both there is a condition. If there is no, we are going to look at it. We have a condition there. So before the condition, let's remove any condition. So without any condition, we have 1, 2, 3, 4, 5, 6, 7. So that is going to be 7 factorial. So let's start looking at the very first condition that we have here. The very first condition we have here is the fact that there are 3 A's, so 3 factorial, and there are 2 R, 2 factorial. So this is the answer without considering the R. But then we move on. After having this one, we want to look at the restriction given to us. In this arrangement, as far as the 2R are concerned, it contains when they are together and when they are not together. For example, AR, A, and so on and so forth, so that another one will stay somewhere else. They are not together. This arrangement contains the situations we have just analyzed. But now they say that they do not, such that they do not. Now the question is that what about if they must come together? Well, if they must come together, we don't see them as 2 again, we see them as 1. So that we are having 1, 2, 3, 4, 5, 6. 6. Now that is going to be 6 factorial. Once again, A is still what? 3 factorial. 3 factorial A. That is for the A. And like we said that the 2 of them, remember that they are indistinguishable. R1, R2. And for the fathers, it could have been R2, R1. Whether R1, R2, or it is R2, R1. The fact is that the 2 of them appear to us as they do not, they what follow each other. So, what we are trying to say here is that after we have agreed that we are having 6, 1, 2, 3, 4, 5, 6 here, divided by the number of A, but we are only treating them as 1, in which it could have been R1, R2, or R2, R1. In that case, we need to multiply it by 2. It could have been this method or this one. So, meaning we have 2 cases of both of them. That is if they must come together. So, now the question they're asking us is that they must not come together, meaning this one without any restriction minus this one with restriction that they must come together. So we have 7 factorial, 3 factorial, 2 factorial minus 6 factorial, 3 factorial times 2 here. So, and you can use your calculator to get the answer. Alternatively, you can just try to factor out some things. We have 7 times 6 factorial here, 3 factorial here. 2 factorial is 2, so let us wait our time there. Then minus what? 6 factorial times 2 over 3 factorial. So what are the common terms? Minus, what we have here is, okay, that is just 2. That is just 2. And we work our way out of this. Alternatively, we can just take out calculator and get what we can have from there. Let's see the first one, and then we move on. So you need to be very careful in the use of your calculator. So factorial divided by, this one is 6, while this one is 2, that is 12. So divided by 12, we are having 420 here minus, here 6 factorial times 2, or let's say this one we also have 2, so they cancel out. So divided by 3 straight. Excuse me. The first one is 7 factorial divided by, this is 2, 2, 2, 3. That is 12. That is 12. Now 420. Why this one is 6 factorial? 6 factorial divided by, okay, 3. Okay, we have 240. So I made, it was maybe something pressed itself there. So we have 240 here. And if you say we subtract that one, it gives us 180. So that is 180 when they do not come to, when they can be made, both are do not come together. So if they do not want, if they must not come together, we have this expression. So yes. So the option is not here because the arrangement is without any restriction. We even have 420. 1, 2, 3, 4, 5, 6, 7. So it has 1, 2, 3, 3 factorial, then 2 factorial. So even with that one alone, we have 420. And we need to subtract something from 420. If you look at the options, all options are more or less in thousands, except 900. So none of them, so it means there is a mistake somewhere in the workings of the options. So the answer is 180. So the next one, we are talking about the remainder theorem on polynomial. We are having 2y squared, no, 2y cubed, sorry, 2y cubed plus y squared minus 3y plus a. This is a as a remainder. So the remainder is 20 when divided by x minus 2. No, y minus 2, sorry. So it means by the time we put 2 here, 2 raised to power 3, 2 raised to power 2 minus 3, 2 plus a. The remainder theorem says that must be 20. So this one is 8 times 2, 16 plus 4 minus 6 plus a equals 20. 16 minus 6, that is 10 plus 4, that is 14. And by the time you transfer it here, 20 minus 14, that will give us 6. So the correct option is B. We have option B as the correct option there. Then we have another one that is asking us to go for division of complex number. Division of complex number. And I will advise you, if you have your calculator, to go straight and do the division rather than trying to spend some time doing the workings. So 3i, that is your z1, and z2 is minus 2 plus 4i. So we have to make some divisions by, we have to operate on this z2. Oh, they call them z2, z3, not 1 and 2. So this is 2, this is 3. It says z2 plus z3 plus 1 over z2 minus z3 minus no, plus I. So not to waste, you can press calculator, that is faster and secured. So this one, we have to add all the reals. So 3 minus 2, that is 1, plus 1, that is 2. And you add the imaginaries, that is 2i, over, you subtract this 2. When you subtract this 1, that will give us 5. And when you subtract this 1, minus 2 minus this, that's what will give us minus 6, plus this, minus 5. So that is, this one will give us minus 2 minus 4, that is minus 6. Then plus I, that is minus 5i. So we can see that then you can rationalize this, or simply you pull out 2 here, you pull out 5 here, so that you're dealing with 1 plus I over 1 minus I. And you can quickly rationalize that. So that will give us 2 over 5 times 1 plus I, 1 minus I, times what? 1 plus I then 1 plus I. If you look at this one, this is 2 over 5. If you look at the first one, that one will give us 1. Then the other one, 2I, while the last one plus I squared. This one is just 1 squared plus 1 squared. When you are multiplying a complex number and its conjugate, just square the real, square the imaginary. So forget any negative that we see there. So this one gives us 2 over 5 times. So 1, and this one is -1, and that one will give us, that one is gone. 2I here over what? This one is also 2. 2 cancel 2. We are having 2 over 5I. So we have 2 over 5I, which is option C. But you can as well use your calculator to get the answer out straight. So as 2 over 5C. So the next one you have to obtain, sorry, we are making it faster because this is just some of the past questions. The revision has been done in the past and the topics have been treated. Just want us to see how sometimes we do things in the exam hall. So express the complex number -6 minus 6I in polar form. So as is geometric form. So if you look at this, it's better off that you even try to, because in polar form we need our modulus and we need our arguments. So we need arguments. So let's work on this one first, which is, so if you look at it well, you could have actually written the 6. 6 is common to both of them. You can pull the 6 out so that you don't work much on that one. And this one, it means 1 squared, 1 squared. So from here, we have 6 root 2 as your modulus. So 6 root 2 as your modulus. And option A has 6 root 2, B has 6 root 2. All the options have 6 root 2. So meaning that none of the options should be dropped. So we proceed to find the argument. So once again, both of them have negative. So forget negative first and let us find 5, in which we are talking about the imaginary 6 and the real 6. And if you look at this, that is 1. Arctan of 1, that is 45 degrees. When you now place it on your Argand diagram, so -6 and -6 here, we have this one, and this is a 45 degree. By the time you add this one to it, making 180 plus 20, 45, that's going to be 225 degree. So the argument should be 225 degree. But once again, we have a little bit challenge here that is not quoted in degree. Instead, it's quoted in rad. So let us now convert this one to rad. We said it earlier that if you move 180 degree, that's your pi. Then when you divide your pi by 2, that's your 90. Divided by 2 again, that's your 45. It means this one is pi over 4. So 45 is pi over 4, 180 is pi. So I need to add both of them together, pi plus pi over 4. That is 5 pi over 4. So that is 225 degree. 5 pi over 4. So we are having, once again, we do not have 5 pi over 4 here. That's now interesting. We have told you in the past that any angle you want to read, any point you want to find the angle, let's say here, there are two ways you can go about it. You can move from here, which is called anti-clockwise or counterclockwise in American term, counterclockwise, and we assign it positive angle, or you can move clockwise and assign it negative angle. For example, you can see 120 degree is the same thing as minus 240 degree, because we are still talking about the same thing. But the question is how. I'm just giving an example that 120 positive 120 is same as minus 240. In other words, I'm not saying of it. Don't let me confuse you that. Let me use 100 instead of that. If I'm using 100 here, now see minus 260. So the issue is this. like both of them look like twins. You have the just like right hand and the left hand. So what is the relationship between both of them? Any angle you know that's already positive before, for you to know its negative part, just say minus 360. And any angle that you know is negative first, for you to know its positive part, just say plus 360. It's as simple as ABC. Now, look at it. This is 100. And I say 100 minus 360 to give me minus 260. And if I have minus, for example, minus 200, if I want to know its positive value, I just say plus 360 to give me the plus 160. So, don't forget we said positive 100 is the same thing. There is no difference except the way you read the angle. Positive 100 is the same thing as negative 260. Now, our answer here is pi all over 4, which is positive. Looking at the options, we don't see plus pi over 4. This is a positive value. You now ask, what is your corresponding negative twin? So, can we know your corresponding negative twin? Yes, we said you need to subtract 360. But this is already in rad, so you don't subtract 360, you subtract 2 pi from it. So when we subtract 2 pi, let's look at it. 4 here, this one is 5 pi minus. So we have it as, in this case, we have it as 8 pi. And that will give us minus 3 pi over 4. Minus 3 pi over 4. And that gives us option D. Option D. We have option D, 6 root 2. Then the angle is converted. Alternatively, just use your calculator and it will give you the answer directly. Use your calculator by putting this one, find the modulus, find the argument, and get the answer straight. We have taught you how to be using that and we have posted it sometimes on the group. So then the next one is find the remainder. Once again, we are having another remainder u. So we have to find the remainder. So find the remainder when we have 2x raised to power 3 minus 7x squared minus 5x plus 4. When you are dividing by x minus 1, you have to find the remainder. So get the zero of this factor. The zero is 1. So put 1 here. 2 minus 7 minus 5 plus 4. So 2 minus 7 will give us minus 5, minus 5, that is going to be minus 10, plus 4, that is going to be minus 6, minus 6. So option C, that is the correct answer to that one. Then we are having another one here. If number 25 now, we are on number 25. Oh, time flies. If the sum of the first 7 terms of an arithmetic progression S7 is 28 and the sum of the first 15 terms, that is S15, is 90. Find the sum of n terms. Well, we know the formula generally n over 2, 2a plus n minus 1d. So all what you need to do is to find your first term a and to find the common difference. So when you apply it here, this is going to give us 7 over 2 into 2a plus 6d. Allow the 2 to enter. It means we are going to have 7a plus 3d. Open the brackets. We are going to have 7a plus 21d as equals to 28 as equation 1. Let's work on equation 2. So once again, we have 15 over 2, 2a plus 14d for this one. So let's do enter same. We have this one turns to a, while this one turns to 7a. D, 15. Then open the bracket again, 15A plus by the time we multiply that one, we are going to have times 4, that is 60, 45, that is 105. That is going to be roughly 105. So we have 105D equals what? Equals 90 as equation 2. You can use a calculator to get the answer straight. So, and that is advisable. Don't that you want to use elimination or you want to use, what's it called? You want to use the other one. Just use your calculator. Okay. So once you know your A and you know your D, so you can put it in the general expression and move on to that area. So the next one here, which is the next one is a surd form. We have to simplify surd expression. We have it as root of 3 over root of 3 minus 1 plus root of 3 plus 1. So when you find the common factor here, so root of 3 minus 1, root of 3 plus 1. This one will give us root of 3 into root of 3 plus 1 plus root of 3. Well, I'm going to look at that, root of 3 minus 1. So this one will give us, you can see that they are conjugates of each other. Just need to square this 3, then you square the other one minus 1. So 3 minus 1 is what you have there. Then on this one, when you open this, it will give you 3 plus root 3, 3 minus root 3. This one cancel out. 3 plus 3 will give you 6 divided by 2. That's one will give us 3. That's our okay. This one is, so we have our 3 there. That is option C. So we are having it in a triangle ABC. So angle A is 30 degrees. Side B is 2. Side C is root 3 plus 1 and okay. Then C minus B, we have to find if A, B, okay. Then C minus, we're having that expression. So it's just like we have angle A given, we have nothing. Then we have this one as 2, we have this one as 3 plus 1. So we have to find this one. You can use the cosine rule to get, or you can even use the sine rule. You can use sine rule, you can use cosine rule, or we use both of them, depending on what you are looking for. So if you are looking for this place, for example, let us quickly find what this one has to offer us. We know this side A using our cosine rule that says A squared equals B squared plus C squared minus 2BC cos A. So when you square this, it will give you 4. You can see it. When you square this, it will give you 3 plus 1, making 4 plus 2, 3. That is for C squared alone. Minus 2, our B is what? 2. Y C is root 3 plus 1 cos A. No, A cos A is 30 degrees. 4 plus 4 gives us 8 plus 2 root 3 minus, this one is going to be a long root. This one itself is This one itself is root 3 over 2. So these two cancel these two out. So we are left with 2 root 3 plus 1, still is what? Root 3. So if we check it out, open the bracket, 8 plus 2 root 3 minus 2 root 3. There's another root 3 here. If you ask us to open this bracket first, what do we have? This will give us 3. What is going to give us root 3? So open it. It's gone. This is minus 6. 8 minus 6, this one is 2. 8 minus 6 is 2. So A is 2. Now, if, let's say this one is B, and we call this one C. If side A is 2, it means side B is also 2. I think we even, yes, sorry, we are doing it like that earlier. Side B is 2, while this one is side C. So, when two sides are equal, we are no more dealing with scaling, and this is now a case of an isosceles triangle. So, being an isosceles triangle, the two sides that are equal, so we have two sides equal, means their base angles must be equal. Angle A must be equal to angle B, meaning this one must also be 30 degrees. So B is 30 degrees, both of them 60, for which C will be more than, that is 180, the remaining part, that is 120 degrees. Now, what is our C minus B? 120 minus 30 will give us 90 degrees. 90 degrees divided by 2, that will give us 45. So, and that is option C, 45 degrees. So you can see how we do this and subtract it from divided by 2. That will give us 45 degrees. So that is under that area. Find the towards the end do. I'm sorry, I'm really exhausted because I've gone through some other activities of the day. So, but nonetheless, let's okay, let us try to do this one. It's been a hectic day. Okay, the last one here, let's take this one as last one here so far. We are dealing with 2i minus 2i. It asks us to find the modulus and arguments. It's a very interesting one. It has no real. So let's see, maybe we should know that one. Okay. Other things are repetitions also. So maybe we should. Which one? Okay. In that case, let's look at this. It has no real part. So what is this? What's it called? The modulus. Since it has no real part, the modulus is even 2. Forget the negative. So in a very short way, the modulus is 2. So it is 2. Don't waste your time. If it has no real part or it has no imaginary, the modulus is that number absolute. If you see the negative, forget that negative. Then another interesting part of this type of complex number is that what is argument? Just place it on your argument diagram. So this is minus 2i. Minus 2i means down a. And if you look at when you read it, it means I'm reading 270. And what is the other way around to read it? We are reading minus 90 degree. Remember that expression. So let's see the options. The options says 2/270. That is option A. So we don't need to waste our time there. And at this junction, we are going to pause and wish you best of luck in your exam. Please try your best and try to make right choices when you are actually dealing with them. Try to know how you can make use of your calculator to short some of these times that you have been spending to solve questions. Several times you have shown us how you can use your Casio 991 to reduce the time in solving some of these things and to even try to get correct answers and avoid some mistakes on the road. So we wish you best of luck
So thank you very much, Mr. Alpha. So we are going to call it a class there. So for those of you that joined today's class, thank you very much. Please endeavor to revise your book very well, and you have to be very careful while choosing your options. Some of the options are similar. You have to be very careful while choosing your options. So with this, we are wishing us success in all our examination. So for those that are having exam tomorrow, we wish you success. For those that are writing on Wednesday, we also wish you success. We wish you guys success in all your examinations. So by God's grace, we are going to call it a class there. So thank you very much for joining today's class. So our next class will be communicated. Thank you very much. So if you have not subscribed to the channel, endeavor to subscribe to the channel so that you can be well informed whenever we go live. So that I can be well informed whenever a new video is released. And also, please always endeavor to ask questions. You can always ask questions either through WhatsApp, or you can meet Afa anywhere in the school, or you can chat me up personally if you have questions, and we are always there to answer you. So thank you very much. We'll call it a class there. Thank you. Bye.
Okay. No, I don't know. I got. Okay, thank you, sir.